Okay, it's 11:05 now. Welcome back, everyone. I think we should continue with the next part, which is the panel discussion. So within the Y project, we have 5 use cases, as Ruth already mentioned just before the coffee break. And we will now have a representative of each of these use cases explain in a very brief 5-minute presentation what they are all about. So the first one in line is Thomas Nacht of Forward Energy Research, who will present the use case of the village of Gnibing. Thomas, go ahead.
Yes, hello everybody. Pleased to be here. Thank you to all the talkers who were before me for the very interesting presentation. So now we go into the Y use cases. I will briefly start sharing my screen. Just give me a second. You should be able to see my screen right now. I hope this works out fine.
Yeah,
So
perfect.
brilliant. I'm here to present the Gleben use case, which is the smallest use cases of the Y project and a very special one it is. First off, let me introduce you to the lovely village of Gnibing, which can be seen on the photo below, with roughly 2,300 inhabitants and roughly 700 buildings. It is a district of the municipality of Feldbach in Austria, in the southeastern part of Austria. And what needs to be said about this region is that they have a very strong focus on the topic of blackout prevention. The municipality of Feldbach is very keen on driving this topic to get people to have a mindset for how to react, how to act when a blackout does happen. And thus also the local grid operator is very keen on going the way to make his entire grid mostly blackout safe in case the superior energy supply stops. So as I mentioned, we have a very strong policy incentive towards blackout effects mitigation. First off, this is on a technical level, but also on a personal level or on a social level where measures are taken to prepare people to be more self-sufficient and more community-driven when something happens, so that people start to help each other. There is a certain infrastructure to it where people can go to once there is the event of a blackout or any other catastrophic event. In Gnibing, as you can see in the picture here, this is the grid of the energy supply company E-Lugic, which is a small energy supply company local in this region. This is just a small grid with approximately, I think they have 200 transformers or something like that. They are a local grid operator and supply company. Due to their small size, they are not unbundled, so both energy supply and grid operation can be within the same company. They have small renewable generation capacities, hydro generation and PV generation, and also they operate the local 20 kV and low voltage grid. And they are quite ideal for this whole purpose because they have everything in one hand. So they have the energy supply and the grid operation in one hand. So what are the key objectives for this use case when it comes to Y? The main problem is once we go into a blackout mode, there is no way to actually simulate that because you are as a grid operator, you don't want to switch off the grid to just see how people will react and what will happen because yeah, that's not where we want to go. So we need some other ways to simulate that. And the special emphasis here is how do people react in a blackout situation if there is some sort of emergency supply? Is there a possibility that they reduce their consumption to absolute minimum if they are informed and the people there should be informed? So what we want to research there is first off, the grid operator or Gnibing itself has a blackout plan for grid operation, but this is only very limited to some buildings that will be supplied during blackout operation, just because there's so much uncertainty on how people will react and what will happen with the consumption. So there are two main issues that we want to research. First off, what is if people were supplied during a blackout with emergency energy, how much generation capacities would be required? How flexible would it have to be? Is the renewable energy generation, the hydropower and the PV enough, or are there additional capacities like backup generators, diesel generators required, and how much diesel will be needed? But also not in the blackout perspective, but in a general perspective of the energy company, what energy services would people accept, which energy services would be good for people to use. And we have defined certain policy interventions. So from a local perspective, we were told that economic and fiscal instruments are very good in that region. So these are the ones, the policy interventions we were going to consider, and also information and communication instruments uh, for energy services, but also for blackout preparation. And the technical interventions would be how people would adapt their consumption behavior in case to minimize their consumption in case of a blackout situation, and then also how they would turn off or unplug all non-necessary equipment that is not relevant in an emergency situation. So what are the expected results? In shortness, because I'm running out of time. As I said, we want to have aggregated blackout load consumptions. We want the required characteristics for the generation. We want to know, because we have the grid data, how is the grid strained during blackout? Is it possible to supply everything? The diesel consumption and the reaction of the consumers, not in a blackout sphere, but in general, the reaction of the local consumers to new energy services provided by the local player, by the energy supply company. So I'm just a few seconds over time, and I give the word back to you, Chris. Thank you very much.
That's perfect, Thomas. Thank you very much. I think that was clear also. So next in line is my colleague Leire, who will present the use case at GoiEner. Leire, go ahead.
Yep, good morning. I will share my screen. Can you see it?
Yes, we can.
Okay. Well, I'm going to explain. I'm Leire Astigarraga. I work at GoiEner, like Chris, and I'm going to explain the second use case, which is the GoiEner use case. Briefly explaining what GoiEner is. GoiEner is a non-profit citizen energy cooperative, which is located in the Basque Country in the north of Spain. We are actually 14,000 partners. We have almost 18,000 contracts. We have 49 workers and 200 volunteers. And while starting with the use case, the main goals or the key objectives of the use case are based in the change of electric tariff that it has been previously mentioned, that we have suffered in Spain. So taking this into account, what we want to see is if a change of electric tariff could lead to changes on energy time of use, to reduce the power in certain power periods, and to reduce the overall energy consumption. And we want to see also if it could lead to foster awareness on energy efficiency, self-consumption, and electrification. If we obtain a positive result, then we could also define a new tariff that improves the previously mentioned factors. Regarding the scenario that we are going to test, it is based on this electrical change of electrical tariff. In this change, we pass from having 6 different types of tariffs for household to have just one. In this tariff, we have 3 different time of use prices in energy and 2 different in power. So taking this into account, we prepared an intervention, which is a randomized control trial. So what we did was we split up in 4 groups or our partners. One group will be a control group, and the other 3 will be the treatment groups, like 3 different treatment groups. So after it, we started an overall awareness campaign using only techno-economic messages. So everybody, each partner will receive a techno-economic message once a month. But then the experimental groups will receive also another monthly message, like it will be a reinforcement message. And depending on the group, because there are 3 groups, they will receive a message with a different topic. So some of them will receive a techno-economic reinforcement message, the others are energy efficiency message, and the others are pro-environmental reinforcement message. So the intervention will last 6 months, and after it, we will make a comparison of the consumption of the different groups. So then we can see which kind of campaign has made the biggest effect on the behavior change. So we can say what kind of campaign has been the most effective one. We will also simulate the different tariff structures that stimulate behavior change, such as innovative time of use, index tariff, or also some special tariffs that can lead to electrification or distributed generation. And to finish, we will simulate the impact that all this has in the greener housing market strategy. And well, to finish, the results that we expect to have, we expect to have a large shift of energy consumption from peak to valley hours, especially in the experimental group, more than in the control group. We don't really expect to see a significant difference between the load profile shapes that we had before the intervention and after it. And the last one is that we expect to be able to define a new long-term market strategy of the cooperative, including also potential changes of tariff. And well, that's the GoiEner use case. If you have any other question or comments, you are welcome.
Yes, thank you, Leire. We'll go to questions later on. Maybe one brief one. Could you just explain how many households are participating in this experiment?
They are participating 10,000 partners, more or less.
Okay, thank you. I think that's important to show that it's really a large-scale intervention. So thank you very much. Well, then we will go to the next use case, which is explained again by Cruz from the University of Deusto. Cruz.
Thank you, Chris. I think that I have this one. So you are seeing my screen?
Yes, go ahead.
Okay, again, it's Cruz Forget from the University of Deusto. I'm going to present our use case, the energy community use case. So just to try to frame the use case, the European legislation is now fostering the active participation of citizens. One of the key instruments seems to be the energy communities, but there is a lot of different definition of what an energy community are. And there is also several pieces of legislation where the energy communities have been introduced and have different characteristics. Okay, so there is a lot of buzzword around this, the energy communities. And now it seems like as energy communities have to be local, it has to be transposed to the national legislation, but it's going to be also need to be transposed to the regional legislation, because this is something that has to be fostered or managed at a local level. I mean, a very, very, very local level, a district level or a city level. So there is a growing interest on all levels and for a lot of stakeholders, because there is a lot of people that could be involved here. But there is a lack of proper tools to tackle the energy community, you know, how to. So the key objective of this use case is to provide tools to help any stakeholder in fostering energy communities. And we will try to tackle questions like the ones that are here, crucially involved. I mean, to what citizens we need to present the energy community concept to try to involve them, how to involve them, what are the right instruments, incentive, is social norms, is to foster legislation, is to foster technical things. When the decision has been taken, how to size the component, how many solar panels we need to put, or is very need a renewable generation district heating, or what type of components we should put into the energy community, and how to size them, and what is the business model, because I mean they have to be a legal entity running the energy community. So what is the right legal entity, and why is its business model? And how to manage all the stuff, new contracts, cancellation, and this type of thing, because the legislation impose, restrict that people have to be able to jump in and jump out of the energy community, and then you need to set the tariff system and the control strategy and a lot of technicalities. So we wanted to try to address all of them, not only the technical part, but also the social and economic parts of the energy community. Okay, so we have been discussing, and we think that we are going to tackle at least two scenarios. One is a bottom-up scenario where a public authority, normally probably a city town hall, that decide to constitute an energy community. For example, in the buildings, public buildings, or the schools, or whatever. The second one is a more bottom-up approach, that the set of citizens, for example, partner of GoiEner or partner of or a building, let's say, wanted to become an active part of the energy system and wanted to become an energy community. How to address them and how to help them to see this vision and to carry out the action, no? And the expected result is that we try to be able to have a best practice guide generated for existing simulation of a scenario using our toolkits. Also, the set, of course, the set of tools to foster this kind of behavioral and social, all the aspects related to the energy communities. And I think that this is my presentation.
Okay, Cruz, thank you very much. Then I'll give the word now to Panagiotis Fragkos of project partner E3M. Panagiotis, the floor is yours.
Thank you very much, Chris. And I hope you can see my presentation now properly. Great.
Yes, we can. Thank you.
So, hello everybody. My name is Panagiotis Fragkos and I work in modeling, which is actually an innovation-based SME from Athens. And in the GoiEner project, we are responsible for developing the European use case. So, starting with a bit of background on what is important about this particular use case, we have seen in the last decade that ambitious European climate and pollution targets have been already suggested for 2030 and 2050. A lot is going on, on preparing the roadmap to get there, but it is not clear exactly how the specific policy instruments can drive the transition, because analysis has shown that, of course, the current policies and legislation are not sufficient to trigger the transition to neutrality. And so more ambitious legislation is required, especially in the building sector, which is, as explained before, is a crucial part of our energy system. And because of the million of users that it involves, it's also one of the hardest to decarbonize. So this European use case aims to analyze and prioritize the most important policy interventions, especially focusing on the building sector, and we'll assess them later using the wide toolkit linked to the Primes model, which is, as Maciej presented before, is one of the main modeling tools also used by the European Commission for its roadmaps, etc. But in this use case, Primes will be, let's say, informed by the bottom-up modeling involved in the wide toolkit. So we have three main objectives in this study. The first is the more, let's say, technical one, where we want to develop a plugin to soft link the wide toolkit with the Primes energy system model. So, in fact, enhancing how the large-scale ESMs model the energy consumption, especially in the building sector. The second is to improve the understanding of how this translates to the energy, to the European transition to climate neutrality. So to improve the understanding of the different options, for instance, energy efficiency, demand side response, electric vehicle integration, and other options to decarbonize buildings. And finally, of course, to analyze the impacts of policy instruments, specific policy instruments to enhance energy efficiency towards the Fit for 55 package, but also for the long-term ensuring the transition to climate neutrality. Of course, the point is that decarbonization of the European building sector is actually something that's quite complex and quite difficult to achieve, essentially as it involves the decision of many millions of people which have which of course poses issues like behavioral aspects, like uncoordinated decisions between the individuals, etc. It also involves the consideration of very important social issues like the energy poverty, for instance, which is a crucial aspect to be discussed, the reduced pollution, which is one of the most important, let's say, co-benefits of this transition. It also involves what is called the Fit for 55 package, where buildings will play a major role, especially with the new policy instruments to drive the transition and the reduce emissions from the building sector. So, so far we have already done our stakeholder workshop where we co-defined specific policy interventions to be assessed with improved primes modeling, and very briefly the results of this point towards assessing both economic and market-based instruments, for instance, the potential integration of buildings in the European ETS sector, and also regulatory interventions, for instance, setting standards in specific buildings or specific appliances. There are, of course, there are also other instruments which are quite important and will be assessed with improved primes model version. For instance, financial instruments, subsidies, potentially targeting those living in low incomes, but also informational and communicational instruments, which are defined by our stakeholders to be quite relevant for changing behavioral patterns across the EU. And of course, this will not be done in isolation, but we will also aim to assess the impacts of the different policy mixes, combining some of the above options towards trying to find the most cost-efficient or most socially acceptable pathway to decarbonize buildings. And the last slide for this very brief introduction into the use case is related to what we expect from our research. So first, we expect to improve our understanding on the impacts on the wider system level of the European building sector transformation towards neutrality, and what will be the impacts, for instance, on the transport, on the power system, etc. Second, we want to examine the feasibility of long-term EU decarbonization pathways, which, as I said before, are now produced every 1 or 2 years. But here we also want to examine their feasibility along several aspects when we actually improve the modeling towards more granular modeling of the building sector, and of course aiming to reassess the ambitious climate strategies for 2030 2050, including of course the Fit for 55 policy package, which will be presented, I think, by mid-July. And of course, finally, we aim to provide new decarbonization pathways for the building sector, which of course take into account the equity and social acceptance aspects on board, and trying to minimize hardship for the most vulnerable groups, for instance, low-income households, while also maximizing co-benefits. And by co-benefits, of course, one of the most important aspects, the reduced air pollution, meaning improved human health for the European citizens. I think that's it from my side. Of course, if you have any questions, feel free to address them. Thank you.
Yes, thank you very much, Panagiotis. Like you say, we will have questions in a minute, but first we will listen to Francesco della Longa of TNO, who will introduce the last and the broadest of the use cases. Francesco, go ahead, please.
Yes, thank you very much, Chris. I hope you can all see my screen. I'm going to put presentation mode.
We can see it and we're waiting. Yes, it's in presentation mode. Thank you.
Great, thanks. So I'm going to present the last use case, which is the global use case. My name is Francesco dalla Longa. I'm a senior scientist at TNO, which is the Dutch organization for applied sciences research based in the Netherlands. So the global use case basically aims at creating some global scenarios, as the name implies. And if you are familiar, for example, with the IPCC reports or some of the IEA World Energy Outlook assessments, these are the type of scenarios that we will be looking into. And we will use two integrated assessment models at global level, TMECN and Prometheus, which might mean something to some of you. The idea is to create some long-term projection of the global energy mix. And we will focus mostly on stringent climate mitigation scenarios, try to keep the temperature rise below 2 degrees Celsius. And as a teaser, I'm putting here a map of the world divided into a lot of colored regions. And this is the regional disaggregation that we currently have implemented in the TMECN model. Our key objectives, first of all, there's a technical objective. We want to be able to fully take advantage of all the insights developed by the WIDE toolkit, so the causal modeling and so on that Cruz described before, in large integrated assessment models like TMECN and Prometheus. And then we want to investigate how this improved representation, especially of the demand sectors, will play out in the global energy mix in a integrated assessment scenario. And within this context, we can do a lot of studies, and the main focus will be to understand what effect of enhanced energy efficiency and all the policies around it will be in our global scenarios, but we will also zoom into certain regions, especially the major economies like Europe, USA, or China. Our scenarios will be constructed along 3 main dimensions. As I mentioned already, first of all, we want to look into stringent emission reduction targets. And we want to look at scenarios with increased deployment of energy efficiency in the demand sectors. Another dimension will be looking more into the costs and the finances. So, for example, some economies already are putting in place some recovery packages. And we want to look at what will be the effect of targeting parts of these recovery packages on the energy sector and on energy efficiency in particular. What we expect to see, the main expected result is that we will gain a better understanding of the system level implications of enhancing energy efficiency in the demand sectors. And under this big umbrella, there are, of course, many things that we will be looking into with our integrated assessment models. And just to name a few, we will look in the long term, how does the global and regional energy mix change, both at the generation side and at the demand side. We will look at the effects on carbon prices and the additional system costs that the different scenarios will entail. And we will look into emissions, of course, how they will change both globally and regionally, and how they will play out between now and the end of the century. And many other things, but too much to list in a few minutes. So that concludes my presentation, and I'm happy to answer any questions during the discussion.
Okay, thank you very much, Francesco. So now that we have heard of the 5 use cases, all on a different scale, from the very local in Gleben to the global scale, as explained just by Francesco, we will try to have a panel discussion and tackle some of the issues which are core to this session. We've all talked up until now about how there is an interplay between models and policy. We've looked at how consumer demand, consumer behavior around energy efficiency come into play, what effect that can have on decarbonization and eventually on climate change. But we're in the EU Green Week, so we need to make the link with pollution. So I would like to give each of you a brief turn on and then explain how the use cases also relate to the reduction of pollution. So I will start again with Thomas.
Yes, thanks, Chris. So I think one of the key factors of the Gleben use case when it comes to pollution is the realization of household consumers on what is actually necessary. So in the use case in Gleben, the scenario of a blackout is predominant. So a scenario where energy is very scarce. Which is not the case today. We have an abundance of energy generally, or at least we act like we have an abundance of energy. So this change in mindset to really go back to the things that are really crucial for everyday living, for survival, maybe then change that to our regular schedule and thus reduce our energy footprint and also our CO2 footprint could be one of the main benefits from a pollution point of view.
Okay. Thank you, Thomas. I'm just reminding the audience that the chat channel is open, so you can pose your questions to any of the panelists there. And in fact, I invite you to do so. And then I will give the floor now to Leire.
Thanks, Chris. Well, in the GoiEner use case, I think that one of the main objectives is to shift the energy consumption for peak to valley hours, and this has a direct connection with the pollution mitigation, because as we know, the energy generation and demand has to be the same at all times. So if we have a bigger demand, we have a bigger generation, and if the generation is bigger, then we have a bigger mix of technologies that are producing energy, which mean they are also, yes, some of them are renewables, but the other ones are not. On the other hand, in the valley hours, we have less demand, less generation, and it's much more probable that we have more renewable energies, apart from the nuclear energy, of course, but we have more renewable energies, so we mitigate pollution if we consume in those hours.
Yes, so we're saying that the non-renewable energy sources are also the most polluting. So if we can avoid having to engage those polluting sources, then we will also. And do you think that's a message that's easily understood by the general public, or that we need to? Yeah, how do we frame that so that this link is easily seen?
Yeah, I think that people maybe has a lack of information of how energy market works and how in which order or why sometimes are, for example, renewable energy is working and other times they are not working, or how this is established. And I think that people has maybe a lack of information on this point. So maybe we could work more on this point to easily understand why we should change our behavior.
Yeah, so it seems that, as Neva said, that the pro-environmental messages should also focus on this aspect, right?
Yeah, that's it.
Thank you, Leire. Cruz, you're next.
Yeah, the energy community, it's a very local thing, and one of the ways that the energy community's use case is going to help fighting pollution, it's in a two-arrow axis. On the one hand, it's fostering the production of energy at local scale. You are reducing mainly with renewable energy source. You are reducing the need for these highly pollutant generators, for example, gas peak generator or carbon or coal generator. And also you avoid, as a side effect, you avoid also the transport network or to need to reduce the needs of transport networks. So it's addressing also other means of pollution. But on the second hand, I mean, trying to foster the energy community, it's not only about it's not about just the electricity and the generator, it's also about geothermal pumps and district heatings and this type of biomass and this type of other energy source that, well, biomass is perhaps not the best case for reducing the pollution, but I mean, there is other generator that try to foster there, but also it's about energy efficiency, it's also about electric vehicles and other economies. So we should try to put this all into the mix and trying to have this in mind to help helping the creation of pollution at the local level. I mean, we need to try to decarbonize the cities, let's say.
Yeah. So it's clear that pollution is often seen as a local problem, whereas certainly in a centralized energy system, energy is generated somewhere far away, and it's like it's on tap, right? You plug in your appliance and it works without even thinking of where what the effects might be because on a local level you cannot see them. I understand that by bringing them into an energy community, that becomes much more visible also to the people, because they can see where where their photovoltaic panels are. They can see where the windmill or wind turbine is and so forth. And if that were to emit, then there would be much larger concern than if it's a clean energy. So
I think that the key word here is empowerment. No, it's when you are in an energy community, you have empowered yourself to be part of the change. No, and the people from learning theory say that this is one of the key points. When you empower the people, you have made half of the process. I mean, the other half is. And the other half is going to be easier. So yeah, you need to empower the people first.
Yeah, man. You mentioned bioenergy. We might circle back to that later, but I will first continue down the line with the other use cases. So thank you, Cruz. And Panagiotis, please.
Thank you, Chris. Yeah, looking at the issue from let's say a macro perspective from the European scale, air pollution is a huge issue in the EU because it leads to a large number of deaths annually, actually. And usually it comes as no surprise that, of course, the deep decarbonization of the European energy system, of course, has a very, very important co-benefit because, of course, decarbonization means reducing the consumption of fossil fuels, or means reducing the burning of coal, oil, and gas. And this directly means that you avoid a lot of pollution, which is created locally, but also at the city level, etc. So this comes as a very, very important co-benefit. In fact, I think that for specific European cities, this can be, let's say, the most important aspect of the transition, actually, even coming on top of reducing emissions. So this aspect of air pollution is quite important. And also, I want to highlight this for specifically the coal regions, where they pay a huge, let's say, amount of annual deaths, cancer incidents, etc., from air pollution. Especially in these regions, it is, let's say, our goal to transform these regions towards more environmentally friendly lifestyle, which means, of course, reducing air pollution.
Are you aware, or do you know of that in certain regions where the system is more carbon intensive, especially coal, because you mentioned it, that there is more public awareness around the link between pollution and the energy system, or is that not so apparent?
I can speak, let's say, from for Western Macedonia, which is one of the most lignite-dependent regions in Greece and, of course, in Europe overall. Yeah, and then I think in this region, they are aware of the problem, actually, because it's their human health, so it's directly relevant to all their lives. So they see the prospect of decarbonization as, let's say, of course, together with the broad socioeconomic challenges that it entails, but they also see a potential very important co-benefit in terms of reduced air pollution and improved human health.
You've just made the link with health, and I think that's a crucial thing, right? As long if we say climate change and 0.2 degrees more, 0.3 degrees more, all of that are for people not necessarily messages that are negative or that they see how they negatively influence their lives. But if we're talking about air pollution, particles, and the direct impact on health, the reaction within people seems to be a lot more intense, let's put it like that. Huh? Exactly.
And I mean, in our use case, we also try we will try to quantify also the avoided deaths or avoided premature deaths, for instance. And this is quite something that using European energy system model results and doing some calculations, you can, let's say, very easily point to the people that look, by implementing this ambitious climate policy, you can reduce the health toll that we all pay by that amount, which is something, yeah, that's very, very easily to grasp, even for someone.
Yeah.
Let's say part of the climate discussion.
Yeah, so perhaps part of the, like you say, the climate discussion should incorporate this because it's something that it's much more difficult to convince people to be energy efficient because of climate mitigation than if we say, well, but it's directly linked to pollution also, right? Yeah. Okay. I see there's a question coming in, but I'm first going to give Francesco the opportunity to reply, and then we will go to questions from the audience. So thank you, Panagiotis. Francesco, your turn.
Yes, well, I think the most important things have been said already, so I can be very brief. I just wanted to point out that by using integrated assessment models, the main thing we can do is to look in the long term at how the energy mix changes in the various sectors, and so there's a clear link with pollution, because we know pollution comes mainly from certain sectors. I think about the transport, think about the industry, and so integrated assessment modeling, even at a very large scale, can still provide very good insights into pollution related effects. Then I want to mention also a couple of other things, because we talk about air pollution, and then of course it's about aerosols and particulates in the air. But let's not forget that greenhouse gases are also a form of pollution. So, and that is something we tackled.
Oh, Francesco, you've frozen. We seem to have lost Francesco.
Type of pollution, for example, nuclear waste, which is also something make some scenarios about. Sorry, can you hear me?
We lost you for a few seconds. Could you recap maybe what you said in the last 20 seconds, please?
Oh, right. I was saying that greenhouse gases are also a form of pollutants, on top, of course, of aerosols and particulates, which is really what we're talking about today mostly. But also nuclear waste is a form of pollution, which, of course, we can very directly make scenarios about with our integrated assessment models.
Yeah. Well, thank you. Those are helpful insights and contributions to the discussion. So the link with nuclear waste, the link with gas house emissions as also a form of pollution. So yeah, we should keep all that within the conversation. So thank you for your contributions. I see now that Macarena has a question. Would you like to present it directly?
Hey, hello. My name is Macarena and I am from the University of Deusto. So my question goes to Leire. Following your question to Nives, you are now working on your experiment. So we are now in summer, we have more sun hours and warmer weather. However, I don't know, but probably perhaps the results would not be the same in winter. We can optimize, I think, that we can optimize the consumption of a washing machine, of an electric vehicle, but however, how we can optimize the heating needs of a household in winter without losing some comfort, at least. Imagine a household with a heat pump or any other electrical heating system. We are not thinking on fuel, on other fossil fuels. So I think that first we would need to make some investments in batteries or any other system. What do you think about?
Yes, Leire?
Yes, well, I agree totally with you, and it's one of the things that we want also to see if people makes different type of investments on those kind of things, for example, in heat pumps or any other thing that could improve the efficiency of the household. So yes, it's a thing that we want to see. And another option, for example, is to heat the water at night. So then you can just sit in the whole day, and it's a way of working, and it's an efficient way, and you can take advantage of those change of tariff. Mm-hmm. I don't know if I have answered to your question.
I think what you mean is linking heat and electricity markets or services, through storage, right? That's yeah. Macarena, do you have a follow-up question, or does this?
It's okay, thank you.
Yeah. Okay. Let's see if we have more questions from the audience. Not at the moment. Yes. Pablo, I see. Yes, Pablo, please go ahead.
Hello. So I just wrote a question. It's about those of you in the project that are going to, like, let's say, gather data or run experiments on the population. It's just if the COVID pandemic is affecting the patterns of consumption, and if so, do you have any ideas on how to control for that in order to the experiments to be sort of like relevant or significant in the hopefully normalized situation in, let's say, in a year or something like that?
Mm-hmm. Is that question directly to the overall, to all the panelists? Or?
Yeah, but I think at least GoiEner is going to do experiments, right? I don't know if the Austria town is also doing that.
Okay, so I'll pass it first to Leire and then leave opportunity for others to also intervene. So Leire, it's your turn again.
Hello again. Yes, well, I will say that yes, we are taking this into account, and we from the beginning of the project we saw that this could be a drawback or so, but I think that it's not in our, I don't know how to say, it's not our, we can't control it. So
it's not within our power to do anything about it. In fact, we're considering it as a sort of a natural experiment also. And another kind of intervention, see how that influences people's behavior and see what lessons we can learn from that and then project it to the future. I see that Cruz is jumping to add to that. So Cruz.
Yes, yes, Pablo, we have been, I mean, we have taken that into consideration and we have reached to the point that for this experiment, it's not going to be such a big issue because we are going to control over the period of last year. So all action are going to be self-controlled. So we are going to compare pairs, or we think we are going to compare peers with peers and apples with apples. I mean, unless the vaccination rate in Spain get a jump and after summer we go all crazy and return to the 20s of the previous century and these type of things. But well, let's see. And in that case, we can also compare with 2018, that is pre-COVID, and we can try to make again the same comparison. In any case, as you probably know, and we are going to explain later on, we are going to also assess these complex behaviors of the people, and we are going to try to assess in which behavior they are. And we are going to try to control with that. I mean, the people that don't change of this complex behavior, we are more or less sure that they have not been so much affected by the COVID. And the people that they change this large scale behavior, let's see what we can say. I mean, because probably they could have a change of a structural change, let's say, of their living conditions, doing for other reasons. And this is one question that we need to try to grasp. Or in other cases, this could be just the COVID effect there that is destroying everything. But our main hypothesis is that those are going to be the less ones. We are not going to see too much structural change of behavior, let's say. But let's see what data says. Because
let's not get ahead of ourselves. That's right. Panagiotis, you also wanted to chip in.
Yes, thanks. Very, very interesting comment. Also for the more macro scale, let's say, use cases. So I just want to say that, of course, also in the European use case, we aim to investigate the long-term impacts, of course, based on the data, because actually the new trends like more teleworking, for instance, can also change, let's say, the consumption patterns, both in the building sector, but also in transport. So less transport use, more energy using buildings. And on our side also, I think it's something that is worth to be analyzed at least, see if it changes and how much does it change also the longer term dynamics of the European scale.
Yeah. Okay. Thank you.
Thanks a lot.
Yeah, Pablo, I think that answers your question. Thomas, do you have any particular to this last question or to the previous section? Do you have anything with relevance to the Gleben case?
Well, for the Gleben case, I think while we will try to consider the effects of COVID on consumption in general, I think the situation for a blackout is entirely different, because while people are more at home during a blackout, hopefully there is no need for teleworking. There is no need for any of that. So I think those effects can somehow be ignored for the general use case in Gleben.
Okay. Yeah. Thank you. Well, that's the time for this panel discussion. I will try and summarize a little bit. So I already did a little bit of that earlier. So the interplay between models and policy that can then link from or bridge from energy efficiency and consumer behavior to decarbonization and climate, but we should bring in pollution. Both from a carbon perspective, but in general from non-renewable energy perspective into this discussion, and the impacts that has on health, because health is clearly closer to people's hearts and considerations. What else have we got here? Sorry, I'm just checking the chat also while I'm talking. Yeah, so nuclear waste was also mentioned as a form of pollution, not air pollution, obviously, but also with its risks. It's a shame that Nieves could not attend this session, because I think a lot of what she mentioned in her keynote speech was addressed here. Nieves, if you're listening to this in later on, then hi, and please, if you have questions, send them to us or send them to any of the panelists, and we will try to answer to you. That gives us time for another stretch of the legs, maybe grab a coffee. And we have a little bit more time now, so we will be back here at 12:10.